Evan, thanks for doing this.
Yeah, thanks for having me.
So let's start with the why.
Okay.
Robotics is not the easiest thing to take on. It is a problem space littered with failures over and over again. You've had previous successful companies. You were in the consumer space. You had 15 million users. You were in YC. You kind of had it all. You know, you're in your 20s. You're in the 30 under 30 set, that kind of thing. You kind of walked away from that path to sort of pursue something different.
Yeah.
So tell me about that.
Yeah, so I did Y Combinator right out of college, and in college I knew I wanted to start a company. I wrote an iPhone app. It got on Good Morning America and blew up, and so that got me into Y Combinator. And my friend from college and I, who's now the Airtable founder, we went into Y Combinator, and we were building a CRM, and I wasn't that into building a CRM, is what I found. Like I'm like, is this how I want to spend my life? And I'm a couple of months out of college. And at the same time, there was a small team in Y Combinator that was building robots. Trevor Blackwell, one of the partners, he had a team. This was like 5 people, and they were building humanoid robots. And this was 2010. This was like way before humanoid robots were a thing. And this thing was like, it was like 8 or 9 feet tall. They've since shrunk them down to be a little less scary. But what was clear to me is these guys were coming in every day, and they were having so much fun. Like they were tinkering and they were soldering, and they had all this like equipment to mill and bend metal, and it was in sort of the back of the office. And I'm like looking at that, and I'm like, and they get to have fun every day, and I'm making a CRM. And so we ended up selling the company to Salesforce, and I worked there for a short bit, but my heart kind of knew where I needed to go. And I think what I realized is when you start any kind of company, it takes time. And you need to be like, if you're in it for the long haul, then I started to see that pattern, that the people that really enjoyed what they were doing, they could outlast and keep going when it's hard, and work like the 15, 16, 17 hour days and have a smile on their face. Whereas I was doing that in Y Combinator, but I'm like,
grinding it.
Like I need a break. Yeah. So that's how I got into robotics.
That's interesting. The observation that if you really, the fire really does come from passion about something.
Yeah.
It doesn't really feel like work, and it kind of keeps you going
100%.
when things get hard, because things aren't always easy in startups. And
Yeah.
I know we'll get into that. Before you really built a company, though, you did spend a lot of time doing some research in the space, trying to understand, what had come before, what the opportunity could be, etc. You did like 100 customer interviews, that kind of thing.
Yeah.
What was a moment that you're like, okay, like not only is this interesting and potentially very fun, but like I actually think there's something worth doing here?
Yeah, so it was pretty early on. So we talked to 100 customers. Actually, I found someone off Upwork in the Philippines for like, I forget, it was like $6 an hour, and she would just email customers. So like the first indication there was something there was she was able to set up 100 phone calls. This person I never met in the Philippines, just sending cold emails, and they would just show up on my calendar, and I was doing like 3 or 4 or 5 a week. And so I'm like, well, that's interesting that this is working. The people have such a problem. And the email just said, hey, like thinking about building a new robot, we think we can make them better in some way. Would you talk to us about it and tell us your experience with robotics and what you want? And so the fact I was even able to have the conversation, and then I talked to these people and I said, what are you using now? How did you program it? What did it cost? Like, how much did you pay to program it versus pay for the robot? And it became really, really clear that everyone wanted the same things. It had the same problems. And it also became clear at that time that I couldn't solve the problems just by building software. And the reason for that is because I heard a lot that the robots are too hard to set up. And generally the way robotics works, as you know, today is you hire an integrator, and often they charge the same as the cost of the robot to come and program the robot and set it up. And so we heard they're too hard to program, and generally you have to hire these integrators, and a team can maybe hit start and stop, but they can't really change anything. So if your part changes or your process change, or your order changed from your customer, if you're making parts for a living, that you're out of luck. You got to go pay again the integrator to come in and fix it. So we heard they're too hard to use. And I realized that we couldn't just add, because when you just do software, what does that mean in robotics? You're adding another computer, and now you're networking that computer, and you still have to go through the setup flow of the robot, and then you have to do the setup flow of this other computer you just added. So I realized, okay, well, I can't create like a great out of box experience adding steps. Like I can't edit the original steps. So and so I heard that, and then I heard they're too expensive, and I learned that 99.9%, like virtually 100% of robots do not come from this country. Despite the fact that we lead as a country, we lead in software, of course, and in high value services, but I come to realize that we're far behind.
Yeah.
And so just realizing how poor the incumbent products were, I knew we could do something.
That sort of really led you to what internally at GC we refer to your garage years. The years where you tinkered around, and you don't have an engineering background.
Yeah.
You're not a trained engineer, but you spent this dedicated time, kind of like learning the fundamentals. Electrical engineering, mechanical engineering, etc.
Yeah.
Can you talk a little bit about that period of time in your life and the things you were able to bring, a little bit like Leonardo da Vinci, like who had this attitude about just taking book learning instead of like putting his own hands into things and learning, by first principle.
100%.
What are the things that kind of surprised you? What are the things you learned? What are the things you thought you had to unlearn?
Yeah, 100%. So my thinking there, so I did computer science in college and economics. So I had that base and, wrote a lot of code for our first Y Combinator company. But I didn't have any formal training in the electrical and mechanical. And actually Trevor Blackwell, the Y Combinator partner who I mentioned, kind of helped get me into this stuff. He didn't either. So I talked to him and he's like, yeah, I think he had done software undergrad. And I'm like, well, how'd you learn the mechanical and electrical? And he's like, I taught myself. And I'm like, you taught yourself? How's that possible? And then he's like, he gave me some books. And so I kind of knew that was possible, right? And when you're so young, you're 22, really, you can learn anything at that point. But it feels like the ink's dried a little bit. You've already graduated college. It's like, but really, of course, you and I know you can learn anything at that. You have so much time and you don't have a lot of costs or expenses or anything. And so I also had looked around and looked at other robotics companies, and I saw the same failure modes. And some that had raised a lot of venture capital. And the failure mode to me looked like subsystem optimization, where you had a non-technical leader in charge and they were letting the mechanical department make mechanical decisions that made sense for mechanical, and the electrical department make electrical decisions that made sense for, and software and so on. But because without a strong technical leader, each of these departments was making suboptimal decisions for the whole. Because of course it's a company and all the engineering decisions need to make sense together. And ultimately you need someone to understand everything to make those hard calls. And you need, the conductor of the band has to understand music and how to make great music. And so I realized I need to be deeply technical in all these areas. And I could see it in software. I could see how, we had a great advantage hiring software engineers because I was a software engineer and I was very technical in software. And I could see how that'd be nearly impossible to hire software engineers if you weren't technical and like really vet them out. So I knew that the same would be true for mechanical and electrical and all these other fields. So I said, all right, I'm going to go deep and I'm not going to raise venture capital at first. I'm just going to, and I thought, should I go back to school? And what I decided was like any curriculum would be less targeted than if I just try to start the company and learn what I need to do to I'm going to be. So the friend and I, James Cordell, he did initially the mechanical and I kind of did the electrical and the software, and so we started building prototypes and spent a couple years. I think of it as like a self-taught PhD in robotics, but
there's those like literally in a garage.
And
that
garage, New York City apartment at one point.
And you, as part of that work, you sort of realized and recognized that the entire stack had to be built. You know, it wasn't just your early observation of, look, having the actual physical robotic device here and having another system over there, adding that complexity doesn't really help. So like, how do I bring the experience and bring the usability more upstream into the product? But like you took this to an extreme. Like you have like, you've counted the number of like, wounds on the motors with a copper wire and like
motor,
like you've gone very, very, very deep. In that, let's sticking to the garage years for a second. What was it about that journey that made you realize, okay, ultimately I actually have to build this thing completely, design and build completely from the ground up, not just relying off the shelf?
Well, we took time to really analyze those decisions, and I think those are important decisions because as a small company, whatever you decide to build, like the what you do and in what order is critical. Like you have very few resources. You need to spend them as efficiently as possible. And so we really tried to analyze, does it make sense to make our own motor? Can we use an off-the-shelf motor controller? Do we need to make our own? And we looked at the off-the-shelf products. We took apart every robot out there to see, what's in there and how do they do it. We really thought through all of these decisions and ultimately realized that we could get much better performance, not just compared to the incumbents, but also for AI and for creating these kind of AI models and robots that can learn from demonstration. And so these things ended up being the most important things to go deeper on the hardware.
But this was a little prescient, right? Because you started the company before the now very famous ChatGPT moment where all of our imaginations suddenly lit up and said, oh, this AI thing might end up working out.
Yeah.
But you were sort of thinking about how to apply this sort of, being taught by observation, et cetera, well ahead of that being obvious to everybody else.
Yeah.
What gave you that confidence?
Well, those first initial 100 customer calls, we heard again and again, like, we want it to do X and it just can't. And so I knew the software had to get better, and pretty early on could realize that the hardware was within reach. There are no huge advancements needed there, although you could make a much better hardware product, but it's the software that's going to be really important. And so looking back at our seed deck, it's the same as our Series C deck. Really, it's we need to create better software for robots, and AI is going to be the way to do that. And so we've been thinking about that for a really long time and working on that and thinking about, how do you make an AI system that the average worker can program? And you have to have someone who maybe didn't go to college, be able to train an AI model. And that's been our focus and has worked out really well.
Okay. So let's take it from there and sort of now build up the product and the market. There's a lot of robotics companies that have in the last year or two kind of popped up, right? Because I think the world sort of recognizes that the physical space, applying AI to the physical space is this great opportunity.
Yeah.
So you've got all these kind of people showing up trying to do that. And the go-to demo, if you will, right, is like have a robot stand up and walk around.
Yeah.
And you took a very different approach in building Stanboss's first products around arms. Let's talk about that decision, and then let's talk about the path to humanoid kind of things and like why it's important to start where you started.
Yeah.
And sort of how that adoption happens in the real world.
Yeah. I think for any product, you want to start with kind of the smallest nugget that's going to be useful to everyone and then increase complexity. And so we realized early on, it's something like 95% of the tasks we've seen don't really need mobility. Probably more than that. Probably 99% don't need mobility. There's some really big ones that do. So we're also working on, we have a mobile base and mobile solutions, but initially it's like, okay, huge market, most manufacturers, because you build your manufacturing plant so the workers aren't walking around all day because that's non-value add. So generally they've got their table and their incoming and their outgoing parts and everything's at that table. So we realized
sort of right there in front of something.
Exactly. Yeah. So we didn't really need mobility for certainly the beachhead to enter. And so we figured we'd start with arms, and we figured out, okay, what's the size we really need to start? Like, is there an 80-20 here? And we figured out what that was.
So tell me more about that. What are the jobs that you think robots should be doing right now? Like if you had infinite ability to take what you've built already and put it into market and get people to adopt that, like you look around, what are the jobs you should be doing right now? Like absolutely it's ready,
Well, I think if we take a step back there and we just look at the macro picture, the United States is no longer competitive in manufacturing, and any one of your hardware companies would say this, which is you try to quote parts in the US versus China, and it's 5 to 10x different. So that big of a jump from like just making any metal part or really anything. And zooming out in that way, if you look at what are robot arms at the end of the day, they're tools. We view them as tools for workers to be more productive, where one worker could do the work of 3 or 5 or 10 people. It's multiplying their efforts, right? And it's a continuation of the Industrial Revolution, and it's this productivity boost. And so what jobs do we need them to do? Well, I think the first thing that robot arms can do for us as a country is get us to be competitive in manufacturing again. And I think a lot of people think of like, oh, why do we really need that? And do we need to be competitive in manufacturing? But actually, if you look at manufacturing, it touches like a third of all jobs and a third of GDP, like the direct and kind of indirect. And so it's really critical to the country. And there's actually bipartisan consensus in Washington right now that we have to have a strong manufacturing base. And we've seen this continued erosion of jobs in the middle class and in manufacturing over decades, almost consistently every year outside of a blip at COVID, because when you're not competitive, things keep going overseas. And so I think we need to, like, go on Amazon, everything is not made here in the US, right? It's like almost everything you get, it's made in China or made somewhere else. And so I think the first thing is just making everything here again, like everything that we use. And it's better for the environment that way. We're not shipping materials to low-cost labor areas and final products back. And it's better for national security. We saw during COVID, we couldn't make masks. We can't even make Tylenol here. Like if there was a global trade war, we don't have any Tylenol, so we need to make more things here. And so I think that's the first thing. And it's important for our balance of trade and our national deficit, right? Like as a country, to have a strong country and have a strong future, we need a strong manufacturing base. So the first thing that robots can do is shore that up. And it's like, we're talking 8-10 trillion a year global labor market for manufacturing. So that's where we've started. But there's so much beyond that. There's agriculture, and there's obviously logistics and warehousing, and eventually there's the home. And robots are going to touch our lives in so many different ways, and not just businesses, but homes too. And so we're excited about all of those markets.
When we did our own work and looked into manufacturing, the state of the art has basically been these robotic arms that speak a very specific configuration language.
Yeah.
They have a I would say a mix of precision versus flexibility.
Yep.
That is very fixed. Let's call it. Those dials are set in very, very specific places. They're very expensive. And so the deployment, the diffusion of these products into U.S. manufacturing, even Europe manufacturing, is actually fairly limited.
Yes.
It's like,
that's right, yeah.
When I know I have a job that needs to be done over and over and over again in exactly the same way for a long enough horizon of time.
Yeah.
Then maybe people will consider it because the configuration cost, the deployment cost, and then anytime anything changes, someone has to come back in and reprogram this thing.
Yeah.
You've both built the software systems, and we'll talk about the impact of AI in a minute. You've built the software systems, but you've also built hardware in a way with a supply chain focus and a focus on cost.
Yeah.
And a kind of rethinking, again, all the way down to the windings on the motors, which I'll never forget these moments with you in the factory, you see this stuff. You've rethought the entire architecture of this product and sort of ground up in order to achieve a different outcome, of consumability, really, of adoption.
Yeah.
Can you just walk me through some of those choices, some of the design things that went into that, and then we'll kind of talk about the AI impact.
Yeah, absolutely. And you're absolutely right. Like the way the products are today, the market is very limited. Like these are products where there's the UI. We bought one of the main competitors, and it took our head of product and I 8 hours to get it to move an inch. We spent all day, and we're like, it became comical after like a couple. We're reading the manual. We're talking to LLMs. We couldn't get it to move, and so it ships without a plug. You have to put your own plug on. It's just 3 wires sticking out the back. So that's kind of the status quo here. And I think in the UIs, like people don't really most people don't encounter software like this and hardware, like we're used to finished products. And so it's way below even like the consumer product. And so that was the status quo. And so we've really thought through our guiding light is how do we design a robot that is for the worker? Like that's been our user from day one. It's someone
not the integrator.
We work with integrators and I think we're going to need more integrators than we have now. But we're not designing for the integrator. Exactly. It's for the worker. It's the person that is currently loading and unloading the CNC mill, or the person. And by the way, I think that with AI, this is important in more than one way. It's important because to deploy millions of robots, they have to be designed for the worker. There aren't enough experts. So like that's just obvious to us. But beyond that, it's really important to design for the worker because you want to bring everyone along for the journey in automation. And I think if you look at the original Industrial Revolution, there was a period where there were workers that did manual textile making, and then they couldn't use the automated textile making equipment. and they were left behind, and those workers suffered. And so learning from history, don't want that to happen again. You want the person that's loading the CNC mill to now be the robot programmer. And the most rewarding thing, I think, for me is when we hear from those people, and these people will get excited. Like they'll go home and they'll be programming the simulator, and especially in the early days, I was deploying the robots myself, and they would like text me and like, hey, I like built, and they build all this stuff over the weekend and like send it to me, and I'd be blown away, you know? And so they're learning a new skill, and they're going to be able to get paid more because their productivity is going to be higher. And so everything we do is designing for that, for the worker, for making it so anybody can set these things up. And then what falls out of that is you need to have like a really great consumer grade experience. It needs to be like an iPhone. Like your iPhone, you don't need a manual for. When's the last time you read an iPhone manual? I don't even know if there is. Is there an iPhone manual? I don't think
somewhere.
There is one. Yeah, there's help pages, but yeah, I mean, like I don't even think it exists. So like that's our goal, is like we shouldn't even need a manual.
Yeah. So how does that lead you to the industrial design you've done all the way down to, you know, what's the torque on, what does the torque on the motor need to be? What are the lengths of the arms? You've designed this beautiful architecture where you can just continue to scale.
Yeah.
You have a Mandelbrot set like architecture of robotics.
Exactly.
You know,
Yeah.
Where you can just continue to scale at different sizes. And then why did that lead to you building your own circuit board manufacturing, which is also, and for anyone listening, like, why is that unusual? People probably don't know where circuit boards come from today. And so like the idea that you have your own circuit board factory out in your shop in Long Island, like it requires a little bit of context.
Yeah, for sure. So starting with the circuit board, so it was during COVID, there was a chip shortage and you just couldn't get enough chips, and the board making companies were so slow, and we built our own motor controller, and we're having issues. And the FETs, which are the switches on the motor controller, there was some software bug, and it was you never want to turn the high and the low side FET on at the same time, because what happens is you're then shorted between, you know, V bus and ground, and so you get too much electricity flowing through, the FET overheats and it explodes, and it's quite dramatic. And it can be dangerous.
That's bad.
These things will shoot out and lodge in the walls and the ceiling. And we had a door, like a blast door. And so to run the software, I put a timer in like 10 seconds, and I'd like run it, and I'd run behind the door and like count and hope it worked. So we just needed more boards, because like you order them from these quick turn houses. I mean, it's so broken today how this all works, but you order a quick turn board. It's supposed to be 3 days. By the time they order parts and everything, it's like 2 to 3 weeks. And you're paying, you know, it's like thousands of dollars per board, and you know, and you don't want to order that many because you don't know if you have a bug, and it's a lot of work to rework them, and so it
interferes with your iteration cycle.
Yeah, like
and you're used to building software.
Exactly.
I can build every hour.
And that's exactly right. So that's exactly what it was, is realizing that, hey, we need actually like a software iteration cycle on our electronics, and that we actually make, you know, that each robot has like 6 different boards, and it cannot be like 3 weeks to know. Like, imagine if you're writing software and it was 3 weeks to know if you have a bug. It's like insane. So I'm like, all right, we're going to be making hardware for a while here. Let's just make this investment. So I bought it myself, like personally guaranteed this line. And this is like 100, you know, or maybe not, maybe it's 50 feet long, but it's huge, you know, huge circuit board line, like state of the art equipment. It's the new version of everything the quick turn houses use. And now we can iterate on boards 3 times a day, because you can line up your bare boards and we assemble it. And for people that don't know, this is, you know, it's putting solder on the bare boards and populating all the chips, and then, you know, heating it through a big 16 zone oven, and then inspection.
Yeah. When I visited your place, you learn all the stuff that you sort of take for granted, you know, like, oh, okay. The raw components, the capacitors, the resistors, the chips themselves, etc., are in this like odd unfinished state, you know, and they have to be kept at a certain temperature and humidity and all this stuff. Then you go through the rest of the manufacturing process, and they bake and they get tested, and you have all of that like literally on a line. And I'd never seen chips on like a roll before, you know. Like, oh, this is where they come from. And I'm skeptical of rules, and so they're like, oh, you need a moisture control, and I'm like, probably not. And then, you know, turns out you do. You have this funny like storage locker.
Yeah, exactly.
Like automated storage locker device.
Exactly.
Safe. Okay, so I think it's a good segue to talk a little bit about AI and the software.
Yeah.
Because we sort of built up a little bit from you design this thing around cost, supply chain control,
Yeah.
iteration speed,
Mm-hmm.
which is a software lesson, and then AI comes in. The LLMs, maybe initially it's not obvious
Mm-hmm.
how a language model applies to making robots more adoptable,
Mm-hmm.
other than like people's imagination being like, robot, go do a thing, like, okay,
Mm-hmm.
sure. But the hard part of the robots isn't that intent, it's the how do I actually get this thing done. So talk a little bit about that journey, and there were these moments I know you had where you're like, oh, this actually changes very deeply how the end user is able to adopt and put this thing to work,
Yeah.
and how quickly they can do it.
Yeah, absolutely. And I think the secret weapon we've had from the beginning is this deep understanding of the customer problem. Like I've seen hundreds, and I've been to hundreds of facilities, and I know, like I have this like really good eval suite in my head of, is that going to be useful? Just in general, whether it's whatever it is in this space. And so we kept an eye on the research from the beginning. Like one thing, I always read papers every week and stay on top. And 5 years ago is like people who had spent their whole career just trying to fold clothes, and you'd go see it in person. And you're like, I don't know. That took 30 years. and so it's like, I didn't look like an algorithm I wanted to adopt. But then what started to happen is, and it's funny because, I know all these researchers now that have published all these papers, but it's a series of these like small improvements that came together that started to collectively make magic. And there was a paper called Diffusion Policy in particular, from Toyota Research Institute. And you just start to see the videos that come out, and then you read the paper, and they were one of the first to apply diffusion models to robotics. And the insight there is, obviously we're using diffusion models for image generation, and they're, and you're learning how to denoise an image, and it turns out that works really well. You can do the whole image in parallel, and you can, and it's just a much better way to generate images, and we're still doing it that way today. And so someone had the idea, well, can we do that to generate robot actions, like the different positions the robot's going to move to? And so it turned out that if you try that, it actually works really well in a way, because if you think about it, if you use autoregressive, if you make one wrong turn, you're kind of committed at that point. Like you've gone left and you should have gone right. But when you're denoising it gradually, you have a lot of tries to kind of get it right. And so that might be one of the reasons these things are sort of black boxes. But for whatever reason, that was one lift. And then there were other things, like someone tried, instead of just predicting one or two positions, like let's predict like 50 at once. And these little kind of changes and tweaks, like they really started to add up. And I saw it and I said, okay, we should bet everything on this. And this is clearly this like ties all the way back to all those customer interviews and all the hundreds of customers I've talked to and am talking to every week. And I can see like all these jobs where I think that could get there with I could see it, connect the dots there. And so we bet pretty early on this. It was in a movie with Nicole Kidman, teleoperating our arms, and that came out like a year and a half ago, and it was filmed like 2.5. So, we've been very early to collecting demonstration, teaching robots through demonstration, where you're training an AI model that's taking in camera data and outputting the trajectory that the arm should take. So end to end. And it can be single model, it can be multiple models put together, but at the end of the day, like pixels are coming in and you're deciding what to do. And that is the big unlock in robotics today. I know a lot of viewers know that, but that's the thing. In these models, they almost feel like they can think, right? Where it's like the first time you use like GPT 3.5 or whatever it was, right? Like where you'll show it some small objects and you'll show it some big ones, and then like, holy cow, it can handle the ones it's never seen, the middle ones in between, and it's interpolating. And some people think LLMs are just interpolating, but their training data is so wide and varied that it feels like they're like an oracle. And we started to see like these models can start to feel that way when you add enough data and you've covered like the set of everything the customer wants to do, where like the things that pop up are kind of in between what you've already shown the model. Really good at interpolating and kind of filling in those blanks for unseen objects, unseen lighting, and unseen environments, and those kind of things. And it feels like magic, and you can interact with it. So you're trying to pick up something and you move it, it just tracks it and corrects. Or if it falls over, if it can learn to just like correct it and pick it up and put it down. And so this is the unlock. And I think there's wide consensus on this. This is the unlock that's going to take robots from what we were talking about earlier, from these kind of niche tools to now to program it. There's no code. You just show it what to do and it can do all these things. We can do all the things. And it's just a question now of, and you don't even have to change the software beyond just the training data. And so that's the magic of it. And that's what we're betting on. And we think it's really going to change the world.
It's also really married to this idea of iteration and iteration velocity.
Yeah.
Both on the model side. So you sort of talk about these changes in the foundation model capabilities around world models, physics, etc. Like, do we think this comes from a lab somewhere, from up on high, and then it's granted to you to use, or do you think like actually, if you take what we have, you put it in the real world, and we learn and we iterate, we're actually gonna make really good progress. You've written a treatise about this, so that is about iteration. The other thing that is about iteration that I think you really leaned into through this was also in the physical product. Like you've added cameras and capabilities, and you've changed the product because this journey you've been on using AI. I think both those things are kind of worth talking about. Let's first talk about the physical stuff, the cameras and all that, and then let's talk about world models and where all that goes.
Yeah. So I think,
how many cameras are you up to now?
Well, we've got some models that'll run off one camera, and then some we use an overhead camera, and you get a lift from having more camera angles. But then there's operational complexity. So one view we have is, it's not all like one size fits all. Like you kind of you don't want you obviously don't want any consulting, but you can have a product that has a couple configurations, a manageable amount that covers that full variety. So it really depends on the job. How many cameras? If you want quick and easy deployment and it's a relatively simple type task, and simple is growing every month, then one camera can work pretty well. I think that, there's things coming out of the lab, and NVIDIA's writing papers, and there's, the new trend is, can we train models on internet scale video and get some understanding of that, learn how physics works from internet scale video, and then like use a relatively small amount of robot training data to be able to do these jobs. And there's some promising work in all these directions. I think the answer is ultimately, like from the labs on high, they'll spend the money on training the internet scale video. That's our view, that some of these things will get commoditized over time, and we don't necessarily need to spend money on training on every video on YouTube. But at the same time, we think we don't think that there's just going to be an NVIDIA model that's necessarily like so great we're ever going to want to just use it. So we take different pieces from different places, and then we're adding a lot of our own training data. We're adding a lot of optimizations. And it's like Apple, right? When you can count on the hardware you have, like we can count on our torque sensing. We can count on the way our arm moves. We can count on, we're not trying to generalize to every robot out there. And so you can really optimize for hardware and get better performance, and optimize for the GPU we're using and max that out. And so we're always going to be editing the model architecture and innovating on that layer. But I think our plan is to kind of like, if it's a bike race, we're right behind NVIDIA and others that are spending the money to train on the internet scale video. And a lot of people are using LLM backbones today. So I don't think you really need to spend money to retrain those. Those are widely available. I think the open ones will keep improving. And the insight there is, if you want to put lots of different robot demonstrations in a single model, if you use an LLM backbone, it turns out that the semantic distance between the words, like I want to insert a memory stick into a computer, or I want to insert bread into the microwave, like the semantic distance between those words is the distance between like how different are the actions. Somehow with language that turns out to be true. It's fascinating. And so you can use a language model to help you store all the demonstrations in a single model kind of efficiently, and call up the right ones when you want to do something with that model. And so we're not training our own LLM backbones and things like that, but we are training everything else around those, the LLM backbones and the open video models, and really innovating there. And we've got some new releases coming out that I think are best in the world on many axes that I think our customers care deeply about.
Some of the results of that have allowed your product to do things that I think would be outside most people's imagination of what, like people just think, okay, robots in industrial manufacturing settings. What do?
Yeah.
Well, they probably weld some things. Maybe they pick some stuff out of a box and put it in a bag. This is
Yeah.
the kind of stuff that people imagine. But you have a robot that's out there sewing, for example. So like you have robotics that's out there doing things I think aren't necessarily what people would imagine.
Yeah.
And it's because it's learned this dexterity.
Yeah.
Because it's able to use AI.
Yeah. And the wild thing is, like and this was a decision at the beginning, you face this, I think, as every company. And the traditional advice is go after your beachhead market. Don't worry about anything else. And we kind of broke all the rules with this company. It's like start with software, only do software. That's going to grow faster. That was the investor consensus a couple of years ago. Mm-hmm. And now, of course, everyone's like getting more excited about robotics and hardware. But the other thing is like start with your beachhead, only do the beachhead. And we did the exact opposite on both those fronts. We started with hardware and we started with a platform because our view was, and I built enough software to know, if I write a bunch of software for one use case, I'm never going to be able to expand it a platform. I'm going to have too many customer requests coming in. We're going to be too distracted just servicing that use case. And it's really hard to then. So we went out and we surveyed, the whole space. Like, what do you need? Like, what are all the things you need? And then built this generic platform beneath. We're like, okay, that can handle like all this stuff. So we have use cases, hundreds of use cases today deployed on our robot, all very different. And that's because from the beginning, we've believed the value will accrue to the platform and we need to be that platform. And it took longer to launch, but we didn't raise venture capital in the beginning on purpose. And so we're really happy with that decision today. But it's so varied, everything that we're doing.
Let's talk about, let's shift gears a little bit and talk about the choices you've made to manufacture in the U.S.
Yes.
And you've spoken a little bit about why you think it's important to just the nation kind of as a whole. And we've talked a little bit about like even going so far as to build your own, ability to create circuit boards and manufacture all that. So you've really started taking this from the design, the principles, architecture, manufacturing, control supply chain. Mm-hmm. So let's talk a little bit about the things you have control over, how you continue to build capability for yourself to manufacture in the U.S. And then let's talk a little bit about policy and why this is important. And the General Catalyst Institute has worked with you to make sure you've had these really successful encounters testifying to Congress.
Yes.
So we'll maybe talk about that a little bit as well.
Yeah, absolutely.
But let's start with the choices to like manufacture, what it takes, and how you think about supply chain.
Yeah, absolutely. So we, from the beginning, we've analyzed, can we make a robot, like if all else equal, you want to make the robot right next to your engineering team. Because if there's a problem, you want the engineers to be able to walk right there and see it. And I kind of realized
and that iteration speed things.
Exactly. Yeah. And it's a product. The making of the product is a product. And I think not everyone internalizes this, but that's one of our greatest products is how to make these robots. And we've got tons of software that help us make these robots and test as people are building it, testing at every step. And we're recording all that data and and so we realized it's this is going to be a lot easier if we can just make them where the engineers are here in New York, like New York City. And so we did a lot of analysis. We looked at machine shops and what are their margins and, and can we do it here? And like bottoms up analysis and top down analysis. And we realized we can. And the reason we can is there's so much waste in a supply chain when you're going to job shops. You're ordering parts from someone and they've got a sales team and marketing and they will need to make their profit and they add insurance and they mail it somewhere and they have to package it up and mail it and unpackage it and inspect it and file a damage claim. And you know what I mean? Versus you just have the machine. And all the other thing is they're setting up the machine for your job, but then they've got 10 other jobs. So they unset it up and and they're programming it every time new as if they've never seen that job before. And so when you're making things yourself, you can have a production line of just machine A and B and C, and all they do is make your parts all day long. You can automate it, which is what our business is. And we realized we can actually lower our costs substantially by doing it that way because of all the waste in the supply chain. So today we've designed almost everything in the robot, not chips, not bearings, and but almost everything else in that robot. And so we're in a position to now bring the manufacturing back to the United States. And that's important I think it's important to our customers. A lot of these people drive a Ford truck and they're proud they make things in America. They want their robot to be made in America.
Should the U.S. ban Chinese robots? And if so, for what applications, for what purpose?
Yeah, I mean, this is kind of getting to the government policy question you asked earlier, and GCI has been an amazing partner, by the way. So I've been invited to testify twice to Congress. We've been engaged in conversations with the current administration at all levels, and really on both sides of the aisle, we've engaged on these topics.
And what's the provocation? What's the Congress inquiry, basically?
Yeah, I mean, it's exactly what you're asking about. It's, should we have a national robotics policy? Like, do we need to do something? And what we've seen is that other countries are interfering in the free market, and including China, right? China is subsidizing their robotics companies and has been. It's on their plan that they put out many years ago, was this is one of the most important things to them. And when you have a government that is subsidizing at national and regional and local levels, it creates an unfair playing field. And so as a country, if we don't want to happen what happened to solar, right, where it dumping very low, a lot of subsidies happening in China, dumping very low cost products, put out, devastated our solar industry, and then venture capital wouldn't touch it again. They learned their lessons, and no one wanted to invest in it at that point. And to this day, we don't have the solar industry that we could have had. And so I think we do need to ban Chinese robots because of the market manipulation. It's, in the perfect world, you would know the dollar value of the manipulation and you would kind of counteract that, but it's not that simple of a world, and it's too hard to calculate. And this is a critical technology for the country. Like, if the technology that helps us be competitive in manufacturing, we don't want these things to be necessarily coming from any country where, I mean, you could have, as you know, a software guy, and we should talk about your background in a second too, but like, if you could have a microcontroller that has a back door, or a circuit board, a motor controller that has a back door, you could hide that pretty well. Or you could push the back door in a firmware update and then shut it down from the parking lot or across. We can't have our factories have back doors where they can just be shut down. And we don't want, and AI-powered robots have cameras all over them. We don't necessarily want our factories having cameras that are, tied to adversarial governments that can see inside of all our factories. And so I think it is important to ban Chinese robots. More importantly, we need a strategy and a policy, because other countries do, and many of, not just adversarial countries, but some of our greatest partners in the world, they have national robotics strategies, and they're now lead. Japan had a strategy; they're the number one in the world. And so I think this is a case where this is so important to the country that we're strong in manufacturing, and that we have this critical technology here that we need a policy to. So that's been what the testimony has been about. Especially
if we consider that we want to reshore some manufacturing, especially for critical industries for the United States. A lot of that's going to happen on the back of robotics labor. That, like you said, they're human operators that are, scaling, and they have the abundance of being able to use robotics and apply to manufacturing. The idea that at the heart of all that is not something that we have supply chain control over. Is it would be puzzling. Right. So
no, exactly. Yeah.
It's very important.
100%.
Yeah. Let's talk a little bit about the future. We had this, we've referenced at the beginning of the conversation, there was this moment where people suddenly realized, oh, there's a breakthrough that's happened in the topic of AI. We were still calling it, machine learning. We weren't allowed to call it AI again, until ChatGPT came out. And it sparked everyone's imagination on what would it mean to have a generally knowledgeable, generally logical, for lack of better words, thought partner that sort of knows a lot about humanity and our words and our language, and what could that do for us? And I would argue that we've mostly in AI been diffusing that breakthrough, which came off the skilled training of a transformer architecture. We must have been diffusing that breakthrough through the rest of the industry, and everything we see now that's very different than the state of things a few years ago has been because we create that unlock of a generalized model around language that we then been figuring out how to apply to different domains. We have not yet had that same generalization breakthrough on the physical side. I argue that when we do, we're going to see as much, maybe more, inference being done in the world on the physical world as we do in the language world.
Yeah.
Because you think about it, like anything with a camera, if it can start to observe things in an intelligent way, well, that's interesting in a lot of different domains. All the way down to your living room TV.
Yeah.
You know, watching someone fall.
The market
you know?
size is unfathomable. How
it is.
Yeah.
So, but you've made a bet on this. What is your view about how we get to that moment, and how well Standardbots is positioned to take advantage of that when that switch really does happen?
Yeah, I think, I think the reason we haven't seen that switch yet is training data. In LLMs, we were lucky because we had collected, we had all these websites, and we had Wikipedia, and we had books, and so all the training data was fairly available. And for robotics, it isn't enough just to train on video, it turns out, because even humans watching video, like you can watch a video, they've done studies, watch a video of people playing basketball, and your confidence that you'll be good at basketball goes up, but you actually don't get that much.
Can't do it.
Yeah.
As it turns out.
Yeah, it turns out you don't get good at basketball watching clips. And so
it's because it's missing the action.
Exactly. So you have to have that action, like, in other words, like the path the tooltip followed or the path the joints followed. Mm-hmm. And that has to be labeled. And it's really hard to label that after the fact necessarily. And so I think that as there are a lot of new ways to collect training data, we can collect it so much more efficiently. And I think we're going to see these models become proficient at, but a lot of what these models need to do is interact with like multi-million-dollar equipment and interact with, in these environments that are so different than the offices that the engineers are in and things like that. So we think collecting the training data in the field is really important. A lot of the training data that matters is the same as self-driving, which is in self-driving, you have the car that falls off the car transporter and it's backwards on the highway and it's not in the training set, and you have to be able to handle that, and so it's like that for robotics too. It's the nines, it's the rare events, and so that's all important training data. And I think that as a leader in this space, and by going quickly on deployments and a leader in deployments, I think we'll have an advantage in training data, being able to collect this from these real customers and real deployments across these hundreds and soon thousands of deployments.
Because you have the hours of the tasks in the actual environment.
Exactly.
You're seeing that long tail of all these cases.
Exactly.
Yeah.
And so I think it'll be more incremental, and I think it's going to be different areas first where the models get really good. And I think of it as it's going to be like the master assembly person who's been assembling iPhones for decades, and now and they can kind of handle anything, and they know the screws cross-threaded, like fixed. And I think it's going to be like the master welder who's been welding for decades, and they know the layup's a little, like there's a bigger gap, like they know how to handle that. It doesn't quite fit, they know to just tap it over there and it'll pop into the fixture. And so these models will become like those experts with all of this knowledge put into them, but I think it's going to be spiky in these areas and it'll fill out over time.
So the product you've built, you built ARMS mostly. You're applying this. Your customers are applying this to American manufacturing scenarios. Yeah. Like, just lay out what the next 5 years looks like, and also with an assumption that there is a generalization breakthrough that happens. Whether that generalization breakthrough happens first, very local to standard bots, like you reach some state where, like, in your configurations, the thing can basically one shot any task is asked to do, or whether the generalization comes from outside work. But like, assuming that happens, what do you think the company looks like in 5 years?
Well, you ran data for Azure, and you're CTO of SAP and Dropbox, and can I turn that around? Because I'd love to know how you think about the next 5 years, having really, you've seen a couple of these waves of complete technological transformation, robotics maybe being one of the most recent ones, and obviously AI in general. But how do you think about it?
I actually argue I've never seen a wave like this.
Yeah.
I guess I was alive when client server showed up, which, you could argue is maybe the last time we had this kind of diffusion of technology that changed fundamentally business and society.
So there's mobile and the internet. And
those are all derivatives. In my opinion, those are all derivatives. Yeah. I actually think AI, the change in AI, the sea change that's happening with AI, it's like the integrated circuit. Mm-hmm. Like it's that unlock. You follow that unlock, and you get mobile, you get internet, you get cloud, you get all that stuff. All that stuff just kind of comes when you start running that program. And the reason I compare a little bit to the client server era is because before that, computers were not diffused into everyday people.
Yeah.
The people didn't have them on their desks. They weren't using them at work. They certainly weren't using them at home. And so it really took that deployment modality, if you will, to start to really take computing
and that would be the internet, right? Like the client being the
even before that, right? You're sort of going back in history to the early days of Microsoft and Windows and all that stuff, and then the internet was this massive accelerant. So I think what we're seeing is this technology breakthrough that's as significant as a transformer, as significant as the integrated circuit. The diffusion speed compared to the client server, which took a decade, is so much faster these days because of a couple of reasons. One, we have people like you around that are like that, just intuitively know iteration speed. It is the path to seeking truth. And two, communication is now instant.
Yeah.
Imagine the world without the internet.
Yeah.
Technology breakthroughs.
Yeah,
like
yeah.
someone builds a new chip.
You
Someone
can just
builds
deploy your app to like millions of,
Yeah, like we can do this instantaneously now. Back then it took, you wouldn't learn about it until you went to the annual conference of the whatever, 9 months later.
Macworld.
Yeah. And then you'd be like, oh my gosh, look at this. And then you start thinking about it.
Yeah, yeah.
But like just that latency is gone. You know, we learn, and I have an AI system that helps me with my work, and it's logged in, it's watching Twitter, and it's like we are learning more about what's going on in the real world from Twitter than from any other channel.
Yeah.
It's because the companies can't produce thoughtful like press releases fast enough. You can't write the news fast enough.
Yeah.
We are now living in a world where the information is coming instantly, and so this is all happening much, much, much faster than any era that I lived through. But what I will say is, and because of that, all of the intuition that we've built over the last 20 years in terms of how this technology gets out is all kind of wrong. It's all going to happen so much faster. And I've seen this in you. I know that, conversations I've had with you in the last couple of months, last time I came by the offices and saw stuff, compared to what you thought would be possible a year ago, things are faster. And everything is actually unfolding much faster. So my challenge to you on the 5-year horizon is like, whatever it is you're about to say, I'm wondering whether or not you're going to completely undersell it,
Yeah. Yeah. Well, I think they're just going to be robots everywhere in 5 years. Like they're going to be in almost every factory. I think they're going to be in most homes too. And I think it's just like the computer. I think when personal computers came out, I think it was the head of IBM, who said, well, I don't know why anyone would want a personal computer.
Yeah, that's definitely true. IBM did say that. Well, this is also the company that famously said, we're going to build like 5 or 6 mainframes, and then we'll be all set.
It's a plausible quote. So, but I think, I know it's like unfathomable that someone would think that. I'm sure it was consensus thinking at the time. And I feel like we think that about robots now. It's like, well, what would I really need it for? But I think they're going to be this, just like a computer has become, or a phone now, like such an indispensable tool to day-to-day life, where the model I like to think of is not the humanoid model. It's not replacing humans, but it's more of the R2-D2. It's the droid that follows you around and it helps you, like the Star Wars droid model. And it's just kind of there in the background when you need something, or when you need to get something done, or you need your kitchen cleaned, or it's like the useful, friendly helper. And I think that's what we see in the next 5 years, is that start the science fiction of our dreams. And I know you're a nerd too, like me. I think that starts to happen and it becomes true, and not just in manufacturing. And so we're really excited for that. And I think the demand and the ability to build a business, I mean, we truly believe this is a moment, like you could build like an Apple computer, an NVIDIA sized business with this, and I just feel fortunate that I get to maybe play a small part of that. So.
It's very cool. Maybe to wrap up, this idea that robots can be kind of everywhere, diffused in all parts of society. Certainly on the industrial manufacturing side, this is an important mission for the country. And kind of reshoring manufacturing, and it's going to require robotics to do it. There's like no doubt. And the more flexible we make these systems, you talk about building a mobile base for it, et cetera, because you just know like, hey, one or more 2 click stops down, you're going to need to have that capability. Robotics in the home also starts this other cycle of innovation, because like when I was a kid, one of the things that sparked my imagination, made me an engineer, was like taking apart the toaster, taking apart the VCR.
I used to love that.
My parents didn't
You
really
gotta
like
watch
it so
those
much
capacitors.
because I take these things
The
apart.
microwave's a dangerous one to take apart.
Yeah, the capacitors. Yeah, stereo components also. You gotta be careful of some of that stuff. Yeah, as I learned as smoke and sparks unfolded in the basement. I would take these things apart enough to know how they really worked and kind of get disinterested and move on to something else. Like a toaster would be gone,
Yeah. I'm sure your parents love that.
Yeah, exactly. But like we want to inspire the next generation of tinkerers. Yeah. And so like getting robotics in the home is going to become important.
That's absolutely right.
Next innovation cycle.
That's a fascinating thought.
So I'm hoping Stereo bots can become part of that.
Yeah.
I'm hoping that 10 years from now, 15 years from now, there's there's 2 different people sitting here. And one of them says, yeah, we had this Bots thing, and I took it apart. I did this thing with it, or I reprogrammed it to do that. That's the kind of inspiration that I'm hoping.
I love that. I love that view of the future, and I think that is so important because even myself, if I hadn't seen Trevor building these robots in the Y Combinator office, I might still be working on a CRM right now.
That would be tragic.
That would be so tragic.
Yeah, there will be no CRM.
We have enough CRMs. One of the things I loved about you when I met you, and Max too, is you guys like go deep on businesses. I think a lot of the VC firms I've talked to, they keep it very surface level, and you can tell from the questions people ask you as an entrepreneur, like how well do they know the space? How well do they know, like how well do they really understand my business? And I love about you and GC is you guys go deep and like really understand things, and having been a CTO of these like major tech companies is obviously a big part of that. Curious, like what got you into robotics in the first place and like wanting to go deep there and invest in this space?
Yeah, I would love to say that like, well, we're just super smart. We knew AI would come and help transform this whole space, etc. And that's not exactly the case. When I first got to the firm, I had actually done a bunch of work on, again, what was still called at the time machine learning before we were allowed to call it AI again. On the back of this thesis that these ex-Googlers who had done the sort of proto-transformer work applied to search knew something about how to apply this sort of sea change coming around the capabilities of machine learning. I glean on the back of that as an example. But I also was thinking about that relative to robotics and thinking, okay, what are all the places where precision has been in the way of adoption? And
what do you mean by that?
So like if you think about like the most beautiful uses of AI today, it's where we have ambiguity and being able to express things in an ambiguous way but get back usable results is like it's like magic.
Yeah, that's right.
This is why Glean works so well. Users express what they're looking for, but they can't express it in a way of the kind of precision required to get exactly what the retrieval answer should be. But Glean solves that problem, right?
Yeah.
It translates that human imprecision or expression, human imprecision of expression into something that is precise, that comes back. And robotics has the same problem. As you said, like these robots are taught to do this specific millimeter scale thing exactly at the millimeter scale. Yeah. And by gosh, if that millimeter becomes a different millimeter, well, the whole thing gives up. And it's like, okay, if you believe that you can apply these emerging techniques into robotics, it should drive broader adoptability. Yeah. And it's very clear there's jobs in the world we don't want humans doing. So that thought process led us to spending more time with Kassar and applied intuition, which led us to learning more about robotics. And it led to the investment in standard bots and led us to the investment in AIM, which is doing level 5 autonomy for like Caterpillar D10s and that kind of thing. And we were looking for these founders, and this is what we found in you, who were not applying what they knew to today's robotics, but instead were able to rethink and had just a different point of view on how this should all unfold.
Mm-hmm.
And when I first met you and you're like, no, I'm building this stuff here in Long Island, for like, okay, you know, like the whole thing was just sounded crazy, you know, because you're like, I care about the number of copper wire windings on the motor. We're like, okay, why is that, you know? And so to kind of like go through that journey with you and learn how you went about rethinking everything from the ground up. And one of the first things you said to me is, this has to be an integrated product, software, hardware.
Mm-hmm.
And that was against my own intuition. And so I'm like, okay, that made me curious. And then it turns out you've taken that principle very, very, very deeply. I remember the story you told me. You built a house,
Mm-hmm.
and you didn't put light switches in the house.
Oh, yeah, it drove my wife crazy.
Because you thought you were going to automate the whole thing,
Yeah.
like Tony Stark's house or something. That work out?
Yeah, then the problem is the power goes out sometimes, and then it's like the middle of the night and all the lights turn on, and you're like, your wife calls you because you're in San Francisco, and you have to tell her to like go to the breaker box in the basement to turn on it. So I don't recommend it.
Maybe a light switch.
Yeah.
Evan, thanks a ton.
Thanks so much for having me.
Yeah.